Sam's talk starts at 3:25. So you have Sam. I met Sam, God, I probably want to say 6-7 years ago in the Hack Miami group. And he's always helped out with everything. He is incredibly bright, incredibly brilliant. And he would never say that part in his bio, but I get to. And then you get to say the rest of the boring stuff if you like. Take it away, Sam.
All right, I'll take it away. See, make sure everything works. See, in the analog hole, for all those old geezers, you may be thinking of something like this, right? The old analog ports in the back of a monitor or something, or VGA, where you could do whatever you wanted with the signal, and then to an extent that's true. What really refers to, for the sake of this presentation, is the fact that if something appears on a monitor or is displayed via speakers, regardless of how much encryption was done on the way to get there, it has to be decrypted for the end user to sing. Okay, I'm Samuel Greenfeld, and I'm your insider threat paparazzi. Got my cameras here, right? Got my long-range Wi-Fi antenna. Got my super sensitive microphones, and some of which are very good at picking up stuff across the conference room. And I'm here to talk to you about how you can use optical character recognition to potentially exfiltrate and occasionally infiltrate data into a company. I'm a CICSP certified. I've been a member of the South Florida ISSA chapter for probably at least 11, maybe 12 years now. And in this talk, we're going to talk a bit of an introduction, look into how OCR works, how some results of doing it, some related attacks, and some potential countermeasures. So, optical recognition, generally these are just referring to automated methods to identify printed or handwritten text in an image. Existed in a crude form as far back as the late 1800s, early 1900s, converting pieces of a character into audio so that someone who was blind could understand what was in the printed text. Started in characters, fonts, now it's much more general. 1960s, this was just post offices looking into it. 1970s, you started to see what you see nowadays in terms of commercial recognition, scanners hooked to just reading a page and then speaking it out, whatever they saw. So it's a very mature technology. Why should you consider OCR as your exploitation method of choice? Well, it's widely available, can be done from outside of a system. You don't necessarily will trigger any alarms on the network if you just take a picture of a monitor. Users have to be able to interact with text. You can't obscure it and then expect a user to do their day job. Text tends to be a limited number of colors and sizes, which makes it real easy to extract out of an image, even if there are pictures or other stuff present. Image precision is generally not super important. We're not attempting to replicate something with exact measurements, like an object, 3D object. You can remove non-text data, which could be used to identify the source. And the focus, at least in my view, tends to be on large data breaches, whereas smaller data breaches may be dealt with quietly or lead to bigger ones. What could you steal with this that would cause a business impact? Well, it could be user data, names, addresses. You could think of this as like a credit card swiper at a gas station or at, some employee at a restaurant. They may get a subset of the data, but it's still a fair amount and it still has a significant impact. They potentially get company data, future financials, internal numbers that people don't know about externally. You could get operations information, AWS keys, which could, in the case of Capital One breach, led to further data loss, or also could be small procedures or things like that. It could also involve product development, future plans, small pieces of source code, other potentially interesting things that are potentially not out yet. And cameras work for monitors and paper. You have them on your beautiful cell phones. Here we have an example of just Samsung's camera app looking at a monitor in a cell phone, and the T on the screen in the circle means it's spotted there's text on there. So it's very happily trying to help us isolate the text on that's there, scan it, potentially OCR it even within Samsung's own applications, and work with it. Some examples of picture-based attacks in the news. In the Netherlands, pictures were taken of 2 data systems used for COVID-19 and data testing and contact tracing. In these cases, the data was obviously in spreadsheet form and would have been real easy to point into an OCR engine and turn back into a text table. In Bulgaria, high-ranking officials spent over an hour just taking pictures of classified information, and they caught them on another camera. Obviously, in the United States, not really an attack, but if you know Digital Millennium Copyright Act, every 3 years you have to get a list of exemptions to it. And the Associated American Publishers would prefer that instead of breaking the encryption of ebooks, in order for the blind and other people to make them accessible to their voice readers and stuff, that they just take pictures of the screen, and even cited how Google was doing that with books. A decade ago, the Motion Picture Administration was making the same claim that if a teacher needed to make a sample of a DVD, they should just point a video camera at the TV screen. And in Colombia, more recently, a call center employer, one which actually has a lot of offices in South Florida as well, requested that employees install cameras in their homes so they could make sure that they were not doing anything to steal their clients' data. Now, some of their customers have come back and said, no, they did not require cameras installed in their remote workers' home, but the call center was trying to push it on them. And the call center also has some other technologies they use, like they use the camera in the computer to make sure that their clean decks policy is enforced with supposedly with AI. And they may also install, required installed on the mobile phones of the employee, mobile device management software, which prevents them from taking pictures and using their phone while they're actively employed by the employer and doing work. So how does OCR work? General first engines will try and just convert things to 2 colors, which are typically represented as black and white. You then rotate the image to a known orientation so you can get at the text. Normalize the size of these letters, both in height and width for the OCR engine. Determine what you're interested in, could be a paragraph, letters, words, depends on the engine. Punctuation is also obviously interesting. And then you process the results. This could be done in a number of means. The crudest approach would be to take an image comparison, such as looking at an A and see if it matches a copy of an A that you have on file. You could look at glyph comparison, where you start taking the letter apart into its individual circles and lines and see if you can identify the letter that way. But you don't necessarily want to just look at a letter. It's a lot more fun if you use neural networks to do this. So you might just, you could do this for just a letter as I show here. But ideally, you would just look at the word and, okay, given this word, what word would I typically see next to it? Just like the keyboard on your smartphone tries to guess what you're going to type next. And you can do the same with OCR. The long short-term memory networks are the type of network typically used for this kind of operation. And if you're taking it using an external device and you're not just taking a screenshot, something else that kind of has to be taken into account, which some engines will actually take into account for you, is perspective correction. So the image is obviously skewed. The monitor is not a bit of a trapezoid, not a rectangle taken from this angle. And you can correct for that to try and make it easier for the OCR engine. And here's an example where we've cropped out and attempted to stretch out and make it look more appropriate. Optional techniques, although these aren't always optional, noise removal. Well, if you want to make it easier, on the OCR engine, you may script language recognition. Especially with printed text, OCR engines could recognize one of hundreds of languages very well. If you're talking about handwritten text, they're not as good. There's only a few most OCR engines can only handle a few handwritten languages. And layout analysis, say you're looking at a printed receipt and you want to expense it for your employer. Your employer may have a contractor in their behalf that takes an OCR engine and looks at the receipt, sees if it looks like another was sent from the vendor and that the prices are reasonable, and you didn't try changing the number to say you had a $50 lunch when you really only had a $5 lunch. And there are a gazillion applications that do this. Mobile applications, software included with printers and scanners when you purchase them. That'd be fine. Company makes a wide range of stuff, ranging from their fine reader projects to original equipment manufacturer software to cloud-based solutions to binaries, blobs you could include in your own program to make them OCR readable. And pretty much every cloud-based solution out there has their OCR engine. Some will even process video, and there's a lot you can do. When acquiring data, there's probably two main means of acquiring the data. First would be page text. So if you're just paging through tables in a database, so you're just taking screenshot after screenshot, and that's one way you could do it. Second type of text, I think, is you typically see a scrolling text, like you're scrolling through a web browser. Here, you could just stitch the text together and potentially error correct as the browser moves up and down. Or a more advanced engine might be able to track the motion data and recognize that the text is scrolling. Some results. If you upload here's an example where if you have image uploaded to Google Drive, you can just open it with Google Docs, and Google Docs will attempt to extract the text out of it. Here's an example where we just opened that document we saw. You can see even saw that the text was colorized and tried to do it. And it's interesting because it recognized there was a table, because you can tell it went down the fiscal year columns and attempted to extract them that way. Here's an example using the Microsoft Lens app. I'm telling it to upload it to OneDrive. An image I've captured to OneDrive is an optical recognized document. And here you can see it kind of did it, but the Microsoft's engines, at least in my experience, seem more oriented towards black and white text. So they got confused, or they get confused by the noise in the image. I've occasionally seen Microsoft engine highlight text in color, but not always. Just to show you that the engine isn't completely broken. Here we're looking at a piece of paper, and you can tell the image correction I didn't do a perspective correction correctly, so the text is skewed, and you can tell in the OCR copy, the spacing is skewed, the tables it recreated, but you notice it did recognize there was a table there, and it was more than happy to recreate it for us and recreate the bullets and everything else that it saw in the image. You can also just do this straight into Word. You don't have to use an app on your mobile phone. If you give Microsoft Word a PDF, which happened to have a picture in it, it'll try and extract it out on its own. You notice it missed the header and the table in this case and kept it as an image, but it got the rest of it as a table. In addition to just extracting the text that we show about and extracting the table that we talked about, Amazon Textract, which is a service in Amazon Web Services, will happily extract forms. It also works with handwritten text and a bunch of other stuff. There's a different AWS service you use if you're trying to extract text from a video. And you'll notice in this case, while it didn't spot the member ID possibly because it was highlighted, unlike the rest of the text, it was able to tell us that the VIP member checkbox was selected, which is something it doesn't tell us in another mode. With AWS, you can also, if it calculates a confidence that it doesn't understand the document very well, you can have it sent on for human review, and then the human will receive, ideally someone in your company can then look at the picture, look at the text that was extracted, and make any corrections that are necessary. Some related attacks, simply take a picture. Don't have to do anything special. You just need your smartphone or something, right? Had this been an in-person conference this year, I'm certain that any number of you would be taking a picture of my contact slide at the end, just going up and going click, right? Or maybe another slide of interest is commonly done, regardless of how much we said we posted the slides onto SlideShare or some other service where you could just see it. Just lately in general, I've just seen people take pictures in conferences of slides, and this is just a perfectly good example of that. You may have to do some image manipulation prior to OCR. Here, we're getting rid of the noise in the image in advance. Although you could tell Google's and AWS engines really didn't care for the noise and plowed through it. So we just did the 2-color conversion using image editing software here to solve that problem. And then you can put it into your engine of your choice if you necessarily have to. You could also use this to remove watermarks, classification headers, or do not copy, or other things that you don't want leaked, such as printer dots. You could just take a picture of the screen. No one said you had to do this externally. If you could just send the file elsewhere, if there's no data loss prevention software, you could potentially use this instead. You might just do video capture. As Danielle mentioned, done video capture for the Hack Miami conferences, as well as one of the Pacific Hacker conferences for their sister organization. And so you just plug a device into the HDMI port, and just as long as it isn't enforcing encryption on the HDMI port, and possibly in certain cases, even if it is, if you have professional grade equipment, you can then go through and video record whatever is shown on the screen, and then process it later with OCR or whatever needs to be done as your threat intel source. Windows obviously also has interfaces used by screen readers, test automation software for those of us who program and things like that. You can use those same accessibility interfaces to dump out a document or a fields or anything. And here's an example where we had that web page we were looking at in Firefox. And here are the accessible insight for Windows tools using, I believe it's called the User Interface Automation Framework now. Formerly, it was called Microsoft Active Accessibility in a previous incarnation. And it's just extracting out paragraph by paragraph everything in the document, and would also include links, things like that as well. Alternatively, if you want to do something a bit more tricky, you could try infiltrating data. If you know that your target has an OCR engine and you can potentially upload something to do that, you could do that as well. For example, as previously stated, you could try uploading a fake invoice, though ideally that would be caught. The catch is if you're trying to upload binaries, that gets a bit more difficult. Here we have at the bottom of the screen the ICAR standard antivirus test file way back in the DOS or Windows 95 days. This is actually a .com file completely in typable characters that you can execute. And even nowadays, if you put this alone in a file and you put a virus scanner on it, it'll tell you this, it's supposed to treat it as if it found an actual virus and trigger off the virus engine. But if you put it in an OCR engine, and even if it's processing character by character, it'll get a bit confused because it doesn't necessarily know, in my experience, if the O is a 0, if the angle bracket's supposed to be a regular bracket. And a lot of OCR engines also try to treat these as words. So they're trying to figure out where to put the spaces in there, even though there's no spaces in there. So straight binary, no, you're not going to necessarily put it in. You could potentially convert this into base 64, but again, you still have the 0 versus O kind of comparisons, or a lower thing. But the more conversions you have to do on the data, the more you have to get to corrections you have to make. It's worth noting you might be able to take base 64 data. It's commonly used in SSL certificates or SSH keys or even AWS tokens or something, and then extract it. And then your OCR engine you can just decrypt it at your leisure, force a font to be trained for the OCR engine, force it to use character mode because you know there are no words in there and things like that. Countermeasures can visually watermark things. This is commonly done as a theft deterrent. This also includes things like putting classified or internal use only on the page. This may include information of the user session being used, the watermark, but it presumes that the data will not be extracted in a way that does not preserve the markup. These need to be present, but they're not overly obtrusive. And with OCR, the primary concern is watermarks the same color of the text. And in this example, obviously, the watermark is not the same color as the text. So if I just forced this to black and white and I didn't care about any of the orange and just forced all the orange stuff to be white, it would be really easy to just get the black text out of the slide. What you may be asking, what if this was an embossed watermark where it varies a bit? That tends to damage the text a bit in my experiments with it, but you can still typically do a 2-color forced extract if you know what colors the text is and they're not playing games with it. And although that gets rid of some kerning of the text, which is kind of what makes the text look nice and round around the edges, it's still perfectly processable by an OCR engine for most of it. You might try avoiding direct recording. You might use an app that forces encryption on the on the display connection or Windows protected media path, Android saying that the output display has to be secure. This is also what causes the Androids, like in your banking apps, if you try viewing them in the history of your applications and switch between them to just so a blank window as opposed to actual values. Imagine you could try enumerating attached video devices. I don't know if anyone actually does this just to see if the name matches something that's obviously a recording device, but I don't know if that's guaranteed to work. Or someone could, if a super dedicated attacker probably could arbitrarily set the name of their device. You try disabling screen capture. But again, if someone has an external device, they can possibly get through it. Rapidly flashing information potentially confuse external capturing, but it'll definitely confuse direct recording chain to take screenshots. But if you have an external device, you can control the shutter speed, you probably could get all the information shown. Adding noise, the same as the text, definitely could cause some problems. You could also try showing a graphical window if you want to avoid active accessibility and things like that. It's hard to say how much you're then the handicapped people could argue are violating the American Disabilities Act, things like that. Hard to say what you could do or not do, but again, all these are basically, if you have an external device and it's not controlled by you, they could potentially do it. You could limit the data breach only by showing a limited amount of information to each user. You could also show different data to different users. And I mean this also like in the sense of if you know that you have test people calling your call center, they could use John Smith with talking to one person as their test call, and they could use Jason Smith talking to a different person. You could also use, you could also do things like obviously show different data to a supervisor as you could to a whatever. Just getting a chat message here, not sure what that is. Okay. You could also do things like corporate policies, training are important in your corporation. Employee monitoring you can always do. You can require device management for all corporate and bring your own devices. This I've seen some taken to a silly extent, but I don't think this is necessarily feasible because you don't necessarily know in most cases if someone's phone they're bringing in is being managed or if they're even agreed in the first place to receive your email on the device. I have seen examples, at least talked about in forums, where people have tried to hook their mobile device management to badge card readers, so that when they badge in for the day, it disables the camera on their cellular phone for a set amount of time and things like that. And you could also look at endpoint of data protection or data loss prevention solutions to try and detect what happened after the fact. But if a human has to see it, other devices can capture it. Optical characterization may help you perform a medium-sized data breach in my experience, but in my view, it may be too complicated for smaller and potentially larger compromises. If all you have access through is through a Citrix or VMware, fully just the display remoting system, OCR may be your only approach to extracting lots of data. But otherwise, there's probably, for simple things like just taking screenshots of a few financial slides, it's probably overkill. And if you can just dump the database, it's probably not something you need to do. And that's all I have. So.
All right. Actually, I really very much enjoyed that. And I want to go back and listen to it because I had to pop out a couple times. You guys can type your questions in or you can raise your hand. And I think everybody's probably taken a picture of this last slide of Sam's. Any questions? Excellent presentation. I didn't even know that some of that stuff was possible. So yeah, you really blew me away on some of that stuff. Did you say that you also gave this presentation at B-Sides Las Vegas?
Well, it was given to Hack Miami, at least in a long form, and it's given to B-Sides Las Vegas with with one or two less slides.
Okay, all right, yeah, because I knew that you had gotten accepted to B-Sides Las Vegas, which was really super cool. I didn't know if this was the same talk that you did there.
I was on mute also. I was asking a question or perhaps making a comment.
Yes.
I think the companies that are offering remote work, perhaps they are still not happy that.
Yes. Well, that's definitely a case where you can exploit this is remote work.
Yeah.
You don't know what I'm doing at home, do you?
Yeah.
I mean, I have my work computer, and well, in my case, I don't have my personal computer on the same disk. I know other people that do.
Mm-hmm. Yeah. Because
you can disable all the USB ports and printing you want, but if I have my I mean, also, a lot of employers have seen news reports implying that sales of remote monitoring software has gone up significantly. So they're looking to see if your keystroke rate is changing, are you actually working, or things like that.
Mm-hmm.
Or are you?
Obviously, they expect you to take a break. So if you're at least take a break, they won't see any keystroke, and if they already rig the camera on the laptop that they issue you, you don't have to, at least you could cover that and then take another cell phone to take the image on the screen or so. So they can't, so I think they are worried. So perhaps sooner or later, they may ask you to install cameras at your home if you want to be.
Oh, that was what I say that one vendor was doing, even though their own clients are saying, no, it was not being installed on our behalf.
Okay.
Yeah, I may or may not know someone that has a bot that gets around the keystroke monitoring.
Well, it's also they're looking at patterns. Is it you typing? I mean, you talk about biometrics. Keystroke typing is one area where they're looking at for, is this the real person using the system? Even with some websites trying to figure out, are you typing in your password the way you always type in your password, or is it something, or is it potentially someone else typing in your password? I mean, and also it's also how many things are you asking? If you're suddenly going through every contact in your contact list, they can guess you're probably trying to leave or something. So that's
neat. Nice talk.
Right. Well, really appreciate that, Samuel. We have